Precalculus, section 6.2, day 1, we're going to be discussing trigonometry of right triangles. A lot of this stuff is just review from geometry. So the trigonometric ratios that we'll be using is Sohcahtoa, where sine is the opposite side over the hypotenuse. And since cosecant is the inverse of sine, we know cosecant is hypotenuse over the opposite side. Cosine we know is the adjacent side divided by the hypotenuse. And since secant is the inverse of cosine, secant is hypotenuse over the adjacent side. And tangent is the opposite over adjacent. And since cotangent is the inverse of tangent, we know that cotangent is the adjacent side divided by the opposite side. In example 1, we want to find the 6 trigonometric ratios of the angle theta. Notice that our adjacent 6 is our adjacent side, 8 is our opposite side, and 10 is our hypotenuse. And we can simplify. Notice that 6, 8, and 10 all have a factor of 2, so we can reduce this to 3, 4, and 5. Now looking at sine of theta. Sine of theta is opposite over hypotenuse, which is 4 over 5. Cosecant is the inverse of sine, so the reciprocal, 5 over 4. Cosine is adjacent over hypotenuse, so we have 3 divided by 5. And then secant is just the inverse or reciprocal of cosine, so 5/3, 5 over 3. Tangent now we have opposite over adjacent, which is 4 over 3. And cotangent is the inverse of tangent, which is also the reciprocal, so 3/4. For example number 2, we have if cosine of theta equals 5/7, we want to sketch a right triangle with an acute angle theta and find the other five trigonometric functions. So if our theta is right here, we know that hypotenuse is 7, the adjacent side is 5. So we need to find the opposite side in order to find all of our trigonometric functions. In order to find our a value, or our opposite side, we need to use the Pythagorean theorem. So 5 squared plus a squared equals 7 squared. So a squared equals 7 squared minus 5 squared, which is just 49 minus 25, which gives us a value of 24. So we know a equals the square root of 24, which reduces to 2 times the square root of 6. So a is equal to 2 times the square root of 6. Now to find sine, we know sine is opposite over hypotenuse. So sine is equal to 2 times the square root of 6 divided by 7. We need to check to make sure we cannot simplify. 2 does not go to 7, so we cannot simplify. Cosecant is just the reciprocal of sine. So 7 over 2 times the square root of 6. However, we cannot have a square root in the denominator, so we need to rationalize. To do so, we'll multiply by the square root of 6 by the times the square root of 6. So we are left with 7 times the square root of 6 divided by 12. Cosine we know. Cosine of theta is 5/7. So secant is just the reciprocal of that, so 7/5. Tangent is opposite over adjacent. So tangent is equal to 2 times the square root of 6 divided by 5. And cotangent is just the reciprocal of tangent, so we have 5 divided by 2 times the square root of 6. However, we need to rationalize the denominator, because we cannot have a radical in the denominator. So this simplifies to 5 times the square root of 6 divided by 12. Next, we are going to review special right triangles. These triangles represent the ratio of the lengths of their sides. So 45, 45, 90. we have a 90-degree angle. We know that both of the other angles would be 45 degrees. If our adjacent and our opposite side are both equal to 1, then the hypotenuse is equal to the square root of 2. And the 30, 60, 90. We know that if the angle across from 30 is 1, we can multiply by 2 when going across the 60-degree side. So our hypotenuse is 2. And going across the 90-degree side, we multiply by the square root of 3. So the square root of 3 is our left side. Think about our angles in degrees. So if we have 30 degrees, we know that in radians, 30 degrees is equal to pi over 6. Sine of pi over 6, we know from the unit circle, or from looking at our 30, 60, 90 triangle is 1/2. Cosine then is the square root of 3 over 2, again, either from our unit circle or our 30, 60, 90 triangle. And then finally, tangent is the square root of 3 over 3. 45 degrees is equal to pi over 4 in radians. Sine of pi over 4 or sine of 45 degrees, the square root of 2 over 2. Cosine of 45 degrees is also the square root of 2 over 2. And tangent to 45 degrees is just 1. And finally, 60 degrees is equivalent to pi over 3 radians. Sine of pi over 3, or sine of 60 degrees, is the square root of 3 over 2. Cosine of 60 degrees, or cosine of pi over 3, is just 1/2. And then tangent of 60 degrees, or pi over 3, is just the square root of 3. For the next section, you're going to need a calculator. And one important thing is to make sure that your calculator is in the correct mode, either radians or degrees. So for number 1, we have sine of 17 degrees. So we need to make sure that our calculator is in degrees. When just typing sine of 17 degrees into your calculator, you get an answer of 0.2923. For number 2, we have cosine of 4. Since 4 does not have a degree symbol, we need to assume that 4 is in radians. So our calculator needs to be in radians. Typing this into your calculator, you then get negative 0.6536. And then finally for number 3, we have cotangent of negative 32 degrees. We have a degree sign, so we need to make sure our calculator is in degrees. And typing this in, we get negative 1.6003. When solving a right triangle, we want to make sure we find all measures of the angles, which there's 3 angles, and we want to find all side lengths. Which again, there's also 3. So there are 6 things that we want to find when dealing with triangles. For example, what do we want to use a special triangle to solve this triangle? Notice that we have a 30-degree and a 60-degree angle, or a 30-degree and a 90-degree angle, so that means we also have a 60-degree angle. I'm going to draw our 30, 60, 90 triangle that we know of. So we have 30, 60, and then 1, 2 is our hypotenuse, and the square root of 3. So to first find WQ, we're trying to find our hypotenuse. Starting with 13, notice we need to multiply by 2 when crossing our 60-degree angle, because from 1 to 2, we cross our 60-degree angle and we multiply by 2. So to find W2, we take 2 times 13, which is just the answer of 26. So our answer for WQ is 26. To find WH, That's the other angle. We know that we multiply by the square root of 3 when crossing the 90-degree angle, so we have to take 13 times the square root of 3, which just gives us an answer of 13 square root of 3. We cannot simplify that any further. And just taking 180 and subtracting off 90 and 30, we get an answer of 60 degrees. So we know the measure of angle Q is 60 degrees. For the second example, we want to use Sohcahtoa to solve this triangle. So first, we have a triangle AMG. So let's label our missing side lengths B and C. So in order to find AG, we want to take the sine of 46 which is equivalent to 15 over C, which tells us that C equals 15 over sine of 46 degrees, and that's equivalent to about 20.85. So we know AG is equivalent to 20.85. Next, looking at our other missing side length, we have MG. If we take the tangent of 46 degrees, that's equivalent to 15 over B. So we know that B equals 15 over tangent of 46 degrees. So we get an answer of 14.49. So MG is a distance of 14.49. To find our missing angle, measure of angle A, we take 180 and we subtract 90 off, and we subtract 46 off, and we get an answer of 44 degrees. So measure of angle A is 44 degrees. You'll notice as you do more problems that there's multiple ways of solving these problems. So if you wanted to find the measure of angle A and then use cosine instead of sine to find the measure of AG, that's totally okay too.